Hello, my name is Stephen Hurd, and today I'm going to be going over some aircraft instruments and the math that they operate on. First, the flight stick and flight controls. While the flight stick isn't an instrument, it is an integral part of the airplane and controls the movements of it. Hydraulics controlled by the flight stick on the right side images move the plane through all three axes: pitch, roll, and sometimes yaw. The throttle quadrant shown in the middle image controls the speed and other parts of the engine. The rudder pedals in the bottom left image control the side-to-side movement of the plane and are mainly used when steering the plane on the ground. Now the altimeter, a pitot system. The altimeter is one of the most important instruments in a plane since it shows the altitude of the craft and is useful for knowing if the plane is too low or other important information. The altimeter utilizes a pitot static system in order for it to operate. A pitot system is a system that uses air pressure from the outside of the aircraft to measure the barometric pressure and other useful information that can be used to calculate the altitude, airspeed, and other factors. The altimeter uses a pitot system by taking the air pressure from the outside, and small parts called aneroids measure the air pressure, since they themselves are already pressurized. It basically finds the difference in air pressure and uses that to calculate the altitude. The altimeter nowadays is mainly digital, since it's easier to produce, but many planes still use this pitot system for the altimeter. The airspeed indicator, another pitot system. The airspeed indicator is a useful instrument to measure the speed of the aircraft, often measured in knots or miles per hour. It measures the speed relative to the air, not the ground, as things like a car would, since a plane takes air resistance into account. This instrument also uses a pitot system to measure the force of the air pressure outside of the aircraft. It then finds the difference between the air in the tube and the air outside of the tube to find the speed of the plane. This is also being digitalized, but older systems still use this technology. The vertical speed indicator, pitot system. The vertical speed indicator measures the rate of climb for the aircraft, and it uses the pitot system to find the air density, since it changes as the altitude increases. The higher the plane goes, the lower the air density, and it can measure the rate that the air density decreases by. The rate of climb is simply the height that you can go up in a certain amount of time, usually 1 minute. VSIs usually show the numbers divided by 100. So if the indicator reads 10, you will be going up 1,000 feet per minute. This is also mainly digital now, but most planes still use this system. The attitude indicator, a gyroscopic system. The attitude indicator is an instrument that shows how the aircraft is moving, whether it's up or down, left or right. The gyroscope in the instrument stays level to the ground, and as the plane moves, everything around the gyroscope moves. This shows things like degrees of bank angles or turns. It can also show the rate of climb on some of them, and it contains vital information for the operation of any aircraft. The heading indicator, a gyroscopic system. The heading indicator is a useful instrument that works somewhat like a compass. It uses a vertical gyroscope to find the heading in degrees of the plane. The gyroscope works by staying still and moving the face of the instrument to show the degrees. This instrument helps greatly during landing procedure, when it could be useful to know the heading of certain runways. Now for some extra instruments. A magnetic compass is a useful instrument that is in many planes and works similarly to the heading indicator. Navigation instruments are also useful for pilots, but many planes don't have them, since many of them are digital and expensive to install. The turn indicator is another helpful instrument in many planes, and it shows the angles of turns and types of turns, like skids or slips. Now I'll point out the parts of the plane and list off instruments that control these parts. The elevator of the plane is what controls the up and down movements, and it's controlled by the flight stick and is measured by things like the altimeter, attitude indicator, vertical speed indicator, and the turn indicator in aircraft like jets, where you must roll to turn. The ailerons in a plane are what control the rolls and turns. These are controlled by the flight stick and are measured by the attitude indicator. The rudders of an aircraft measure the side-to-side movement, and this is controlled by the rudder pedals and possibly flight stick in some aircraft, and it is measured by the attitude indicator and the heading indicator. Finally, the engines. These are controlled by the throttle of the plane and is measured by the airspeed indicator and vertical speed indicator, somewhat, since it measures the speed of the aircraft up and down and not the speed directly. To a large extent, almost every aircraft that pilots use have these simple yet effective instruments and controls, and it is almost impossible to fly a plane without them. Many of these tools are becoming digital now, since they're easier to produce and easier to read for the pilot. Using these instruments are vital to the operation of the airplane, and pilots rely heavily on them while they're in the air. Thank you for your time.